Welcome to the podcast Solving Systems of Linear Inequalities. Before we begin with linear systems, let's recall what it is to graph a simple linear inequality. And recall the basic rule that the graph of a linear inequality is a half plane. Now, what's a half plane? Well, what that means is if you draw a line in a plane like this, a half plane is either all the points below the line or it's all the points above the line. It's never part of the points below and part of the points above. And one thing that's important is without a line, there are no half planes. So let's suppose that we're asked to graph this linear inequality. There's two ways to graph a line. And by the way, the line you use to establish your half plane, you get by just changing that to equals. Now suppose I want to solve this inequality for y. That would be one way to graph. If I want to solve it for y, I move my 3y to the right, where it becomes positive 3y. I move my 6 to the left, where it becomes positive 6. And I get 3y plus 6 is 2x plus 6 is greater than or equal to 3y. I divide both sides by 3. And I get that 2/3 x plus 2 is greater than or equal to y, or the way we normally see it is y is less than or equal to 2/3 x plus 2. Now I can graph that using slope or rise over the run. The slope is 2/3. That's the rise over the run. The y-intercept is 2. So if I come out here and I mark the y-intercept, and then I do a rise of 2 and a run of 3, that'll get me at a point here. And if I do a rise of 2 and a run of 3, that'll put me at a point here. And similarly here and here. And so this is the line from which we can determine our half planes. Left a couple little gaps in the line there because I didn't press down hard enough with the pen. And the next thing we would have to do is we'd have to decide, well, which half plane is the solution half plane? Well, if you've solved for y and it says y less than, then the solution half plane is the region below the line. There's another way to determine that region if you have not solved for y. Pick a point not on the line, like for instance pick 0, 0, because that's not on the line. And if I plug in 0, 0 in my original equation, I get 0 minus 0 is bigger than negative 6. Well, that's certainly true. That says that 0, 0 is in the half plane, which again says that the half plane is the region below the line. So I've indicated that with these downward arrows. Now what we're going to be doing is solving systems. So let's say that we've got a linear system, and the first equation in the linear system is 2x minus 3y is greater than or equal to negative 6, and we add a second line to our system, or a second inequality to our system, and just to keep it simple, I'm going to say y is greater than x. And so now a solution to the system would be a set of points that satisfies both inequalities. Well, let's see about the points that satisfy the second inequality. The line that we'll be graphing, of course, is y equals x. So when x is 2, y is 2. When x is 4, y is 4. When x is 6, y is 6. When x is 0, y is 0. So I get the following line. And I'm just coming here and keeping my y's and my x's equal as I go. And there's my line. Comes out on this end like this. This is the line y equals x. This is the line y equals 2/3 x plus 2. Now, what points would satisfy this inequality? Well, it would be the points where y is bigger than x, but in the last case, to determine it, one thing we did was we plugged in 0, 0, and we saw whether 0, 0 was a solution. Here we can't plug in 0, 0 because 0, 0 is on the line. It's not above it or below it. So we have to pick a point not on the line to do that test. So I'm going to pick the point 2, 0. That's not on the line. And I'm going to plug it in. That says x equals 2, y equals 0, so I get 0 is greater than 2. Well, that's false. So I know that this point is not in the solution half plane for this line, so the half plane must be the points above the line. So there we go, drawn above. So in order to be a solution to the system now, it has to satisfy both. So it has to be above the upper line and below the lower, above the lower line and below the upper line. So that would be these points that are in this kind of narrow wedge. They're the only points that are below the upper line and above the upper line. There are none when you get out here. Out here, if you get below this line, then you're not above that line. So there are no points that satisfy both. Now, the solution then is this infinite wedge that goes all the way out here to negative infinity in the x and the y. Now, a lot of times in these kind of problems, the quantities x and y will represent elements such as grams of a food or parts of a machine or computer chips or something, and you can't have a negative number of those. So many times in this kind of problem, we'll add what are called non-negative constraints. And if x is not going to be negative, that would say it's greater than or equal to 0. And if y is not going to be negative, that says it's greater than or equal to 0. So if I was to take this system and I was to add the non-negative constraints, what would that do to my answer? Well, if x is greater than or equal to 0, that means I'm to the right of the y-axis, because that's where the numbers are that are bigger than 0 for x. If y is greater than 0, that means I'm above the x-axis, because that's where the positive y's are. So if I'm to the right of the x-axis and above the y-axis, that puts me in the first quadrant. And so what are the solution points in the first quadrant? Well, that cuts out everything not in the first quadrant. So the solution points of the first quadrant turn out to be just this little triangular wedge of points right here. And these points are thrown out of the solution. So that's a typical problem of solution of system of linear inequalities, and that completes the podcast.